We're going down the intake runner. So you can see this is my cylinder head. That gap right there is my intake to cylinder head. So the gasket's going to be right here. Valve. Here's my intake valve. Oh my Lord. Look at that carbon. It looks wet. What's up, guys? Welcome back. Got some bad news. Ended up running into some engine trouble with the Mustang, and as tradition goes with this car, it's an extreme issue. It's not just a little issue we can keep running. We're blowing smoke out the tailpipe now on a high RPM pull. So here's the footage. Hey. Go. Oh man, that thing is fast. Oh, bro! And that video is actually me racing my WRX as well, and we kicked butt, so that's all that matters. But now we have a coolant leak, a suspected coolant leak in my engine, and it's somehow getting into the combustion chamber. So what the point is of this video is I'm going to go through and introduce you guys all the tools that you would need for major engine diagnostics. Checking piston rings, checking head gasket sealing, checking intake manifold, just making sure oil is where it's supposed to be and coolant is where it's supposed to be. So I'm going to introduce you guys all the tools I have here, and then we'll go through and show you how I'm going to fix this issue. So guys, if you're not aware, my Mustang has a 351 Windsor in it, and that a 351 Windsor comes from the small block Ford engine family, which means it has push rods. So for this particular engine, coolant can only enter the engine in two areas: the timing cover, and if your timing cover leaks, you only get coolant into your oil, not the combustion chamber. Intake manifold. Intake manifold can leak coolant into your oil, which would be in your oil pan, and it can also leak into the combustion chamber if it gets into the intake runner. So I saw the smoke when I was driving the vehicle and I didn't see any blue, so coolant is suspect at this moment. I'm going to introduce the tools that I'm going to be using today to check the engine health, or to check the health of my engine. I'm going to explain what the tool is, when you would be using it, and I'll roughly show you guys how to use the tools. You can always look them up online for a more in-depth tutorial how to use them. So my first tool right here is a torque wrench. This specifically is a digital torque wrench, but the first thing I want to do is I want to check the bolt torque on the intake manifold, because I have a suspicion that my bolt torque loosened up and the intake popped up, and that's how I'm getting coolant into my cylinders. Because as you can see already, any engine checking engine health, you should start with the spark plugs. I pulled these spark plugs and they're already starting to tell me some information, and it's apparent that it is not one cylinder that is receiving coolant. Multiple cylinders are receiving coolant. I'm not going to go in depth about how to read spark plugs right now, because I could make a whole video on that. There's a lot of witchcraft and fascinating science that goes to reading spark plugs. But yeah, so now let's move on to the next tool here. So this is cylinder leakage testing kit. This is OTC is the company. So what this tester does here is we're going to be pressurizing the combustion chamber, specifically using compressed gas from a compressor. So you would be using this tool, checking one cylinder at a time, and you would have the piston at TDC on compression stroke. You need intake and exhaust valves to both be closed when doing a leak down test. As you can see, one gauge So normally, some leak down tests, one gauge is in a percentage, and then your feed gauge is in PSI. This kit has PSI on both gauges. The difference with percentage on one side is the gauge is actually already showing you how your percentage of loss of your air in the combustion chamber. This just shows PSI, so we'll have to time ourselves and watch how far this drops. The kit will come with different adapters for different spark plug sizes, so you just want to make sure that you use the right adapter for your cylinder heads. So this is basically the best way to do a health check on the entire combustion chamber. You can check piston rings, head gasket, and your intake and valves sealing against the head, all at the same time. Next toolkit is a compression test kit. This is going to be pretty similar to our leak down kit, however there's only one gauge. There's different adapters for different spark plugs. The way that you use this is you crank over the engine. You're measuring one cylinder at a time, and you crank over the engine, and the actual piston coming up on the compression stroke is what provides the pressure for this. And this is also a good tool for checking your compression rings on your piston, checking head gasket, along with your intake and exhaust valves and sealing against the head. In other words, this is only checking one stroke on the compression stroke, and it's reading the highest pressure possible during that compression stroke. This is measuring the integrity of the entire combustion chamber for an extended period of time. Last toolkit, since coolant is suspect for this failure, we have a tool to pressurize the coolant system. So this extra piece is for, you put a radiator cap, so you can check the cap itself, or you would take this shiny stainless piece off and you would put this right onto your radiator and you would pressurize your coolant system, and this is going to allow us to look for leaks throughout the engine. Last tool that majority of you guys are probably not going to have or have access to, but this is a borescope. This comes in extremely handy for convenience. Basically, this allows me to check the inside of the engine before I take anything apart. This tool is more of a convenience thing, but it never hurts to have as much information as possible when doing a health check on your motor, especially when it's something this major. This borescope right here, this is the camera, and I have a knob where I can change the position of the camera. The camera's on the end right here, and I can use this joystick to move it around to see what I'm looking at. And this borescope also has the capability to take videos, pictures, and I can actually change the light setting on the camera. So while you're disassembling the engine, it's also extremely important to take pictures as you go, because as you move gaskets around and take them off, you'll start to manipulate and hide clues that you wanted to see. So you want to take one part off at a time and look to see if you can see oil and coolant leaking into the other ports, and just take pictures as you go. Alright, so the first thing I'm going to do is I'm going to go through and check the bolt torques on the intake manifold. So what I'm going to be doing is I'm going to be setting this to 5 foot-pounds, and I'm going to go around 10 foot-pounds, go around 15, and work my way up. The torque spec for these bolts is 18 to 20 foot-pounds. So I'm basically looking for a bolt that's going to make this torque wrench click, or in my case beep, and hopefully we don't find any under the torque spec.
Rage on that beat, going crazy.
And I found 4 bolts that were loose. That's more than enough for me to stop, and I know that there's bolts loose. That's most likely the cause of why we have coolant getting into the combustion chamber. And I'll show you more on the borescope of how coolant is getting into the intake runner. Just for fun, you guys want to see what a cylinder looks like? I'm sure you do. So let's see. Oh, there's our piston. I'll show you guys those are threads for the spark plug entering the combustion chamber. So we can still see cross hatching. That's good. Let's take a look at our piston. So normally when you're looking for wear on pistons, you want to look for sharp corners. So you can see I have valve reliefs right here. We're looking for any form of cracking on the crown, which is the very outer diameter rim of the piston, along with the valve reliefs. So the cylinder looks okay. So we're going down the intake runner. So you can see this is my cylinder head. That gap right there is my intake to cylinder head. So the gasket's going to be right here. Valve. Here's my intake valve. Oh my Lord. Look at that carbon. It looks wet. Oh, do you guys see that? That's water. That's right where the valve seals on the cylinder head, and I can see green water sitting there. Along this, it looks like it's right above the 45-degree seat on the intake valve. That's sitting water. So I went ahead and checked the other cylinders too. So now we know that water is getting into the engine above the intake valve. So what does that tell us? It's not a head gasket. So the next step I'm going to do is I'm going to pull the intake manifold off. I'm going to be taking a lot of pictures of what the gasket looks like from the outside. So I want to try and preserve that gasket to the best of my ability, because that's where I'm going to get the root of my information on why this happened. The next step I want to do now is pull the drain plug and get an understanding of how contaminated my oil is. So I have a tool to cut the oil filter. So I'm going to remove the oil filter, cut the metal housing, the metal outer housing off, so I can look at the paper filter element inside to get a good understanding of how much metal is in there, and if I have severe wear or not with my bearings, cylinder walls, and so on. So with that said, let's pull the drain plug. So like I was telling you guys, oil will sit on the top of water if you have a lot of water in your oil system. And you saw that the first liquid to come out of the pan was oil color. So that's good. All this is really telling us is that there's not a lot of water in the oil. There still can be water in the oil, but there wasn't a significant amount to notice that there was a separation between the two. Cool little trick. This is a magnet. If you guys don't have magnetic drain plugs or aren't able to buy them for your style oil pan, I actually just stick a magnet on the bottom of the oil pan to try and hold on to any iron metal that may get in the oil pan. So that's my little cheap backyard trick. Alright guys, so we got the intake manifold off. We determined that root cause was the bolts for the intake manifold coming loose. So now what we're going to do is we're going to carefully try and take the intake manifold gasket off, and we're going to want to look at the compressed parts of the gasket and see how wide the compressed part is to make sure that we are having good seat contact between the cylinder heads and the intake manifold. The reason why you want to check for stuff like this is because used cylinder heads or cylinder heads that you're not aware how much material has been removed from the deck surface, or if you have used cylinder heads or used intake manifolds, you don't know if anyone's removed material from the mating surface, and that changes the way everything fits. So we want to make sure that the angle and the height and everything is correct for what we need for our application. However, we are pretty certain that the bolts coming loose was the issue and not a contact issue, but we just want to confirm while we're here. Okay, so you guys can see this port right here and this port right here are coolant passages, and then the ports back here and the ports back here are coolant passages as well. The gasket between the cylinder head and the block coolant from flowing from the block to the cylinder head, so it forces the coolant to flow up through the back of the cylinder head and make its way to this port, which enters the intake manifold and then goes to the thermostat and then back to your radiator. So if you guys can see the color difference between this and here, this is our compression. This is where the intake manifold was touching, and you can see how wide this is. That's really good, how wide this is over here. We're also going to look at all the blue around the ports and make sure that it was compressed all the way along the blue lines. And we're kind of just looking for stuff like this. You can see the raised part of the gasket that wasn't compressed at all right here. So this is what I mean looking at the compression mark on the intake gasket, because we want to make sure we have a good fit. And it looks like this gasket fit very well. The intake fit very well with the cylinder heads. So our issue was in fact the bolt holes coming loose. In theory,
You need to show you the side that you're on.
in theory, I assume that coolant was being pulled from here into this intake port, and same for the other side. And I have a pretty lumpy cam with some decent duration, so during low speed idle, the Vacuum pulses from the intake stroke probably moved the coolant throughout all of the cylinders, and that's why I found coolant in all of my cylinders. So on the intake manifold, this is a coolant port. You can see I can actually touch the thermostat back here. And then these are all intake ports. You can see it's blocked. The coolant is blocked in the back here. So it only crosses through the front on small block Ford Windsor family intake manifolds.
Yep, so coolant was going from this port into the intake port, getting kind of tossed around the manifold, going to all the cylinders, and then getting burned up and coming through the exhaust, which is how we initially found the problem.